Today we will be learning about solution conversions. Our target is to convert from one concentration unit to another. Our key is to identify the solute and solvent and then to label all of the units. That is especially important, labeling everything to help guide through to the final concentration. So our first example. Concentrated hydrochloric acid is usually available at a concentration of 37.7% by mass and a density of 1.19 grams per milliliter. What is its molar concentration? Okay, so we know we're going to be solving for the molar concentration of the hydrochloric acid. So let's look at what we're given. We're first given the density of this acid. So density is mass over volume. So our density is 1.19 grams over 1 milliliter. If to say we assume this says that basically that every 1.1 grams of the hydrochloric acid there is 1 milliliter. And so we know this is of solution, the solution of hydrochloric acid. And so we know that. And so let's skip back to what we're solving for. We're solving for the molar concentration. So we know that molarity is the moles of solute over the liters of solution. So from this, we have milliliters of solution, and so then we are able to know that with 1 milliliter, you would take 1 and milliliter, and then you would move over 1, 2, 3 decimal places, and that would be 0.001 liters. So if we rewrite this to know what we're solving for, so we have a blank moles of solute, and the solute is the hydrochloric acid, or and then we need so we have the liters of solution, which would be 0.001 liters. So now we need to find the moles of the hydrochloric acid. So we have the grams of the solution, but a key part is that it says the concentration is available at 37.7% by mass. So we need to find what is 37.7% of 1.19 grams. So you take the 1.19 grams and you're going to multiply it by, if we make this a decimal instead of percentage, because you can't really multiply percentages, you would move this over 2 decimal places to the left and be multiplying by 0.377. And then afterwards you would, of course, multiply by 100 to get it back to a, or wait, no, you would not multiply by 100 because you're getting it to grams, not a percentage. So this would equal, and then let's plug this into the calculator. So 1.19 times 0.377, and that gives us 0.44863 grams that we were going to, but we're still looking for moles, not grams. So now we need to take, and this is of HCl, we need to take the 0.44863 grams of HCl, and we need to convert it into moles. So if we get a periodic table, we know that 35.45 plus 1.01 for the molar mass of HCl. So we have 36.46 grams of HCl per 1 mole of HCl. And now if we just plug this into the calculator, we get 0.0123 moles of HCl. So now if we put this into our molarity equation, 0.0123 moles of HCl per 0.001 liters, and then if we divide this number by 0.001, we get the molarity to be 12.3 molarity of HCl. So this is our final answer. Now we have one more solution example. So in an aqueous solution of sulfuric acid, and just so we don't get confused, sulfuric acid is H2SO4, so we know that so we don't accidentally calculate and convert to the wrong thing. The mole fraction of the acid is 0.0240 moles, and the density of the solution is 1.079 grams per milliliter. Calculate the molar concentration of the acid. So this is actually a mistake here. This should be a lowercase m because lowercase is molar. So what molar is it is the moles of solute over the kilograms of solvent. Now the difference between solute and solvent, of course, is the solute is the solid you would add into the solvent to create the solution. The solvent is like the water or whatever liquid that you use with it to create the solution. So we need to find the moles of solute, kilograms of solvent for our molality. Okay, so we're given the mole fraction of the acid. So the mole fraction is the moles of solute per moles of solution. So if we're given 0.0240 moles of the acid as the mole fraction, so assuming or knowing that this is 0.0240 moles per 1 mole of solution, you would have 0.0204 moles of solute, which is the H2SO4, over 1 mole of the solution. Okay, so this is our mole fraction. So this gives us the moles of solute. So we know that there is 0.0240 moles of the H2SO4. And then now we still need the kilograms of solvent. So let's take a look at our density. So from before, we know the density equals mass over volume. So in this case, our density is 1.079 grams. And keep in mind, this is of solution. So we know, because fraction works, as this would be 1.01 per 1 mole over 1. And so we know that there would be 1 milliliter of solution as well from the density. So we're looking for kilograms of solvent, and this is all solution. But what we can do here is we know the moles of the solute, and we know that moles of solute plus moles of solvent would equal moles of solution because they're added together to create the solution. So if we take the moles of the solute, and convert it into grams, we would have, if we take the, so we know we have 1 mole of solution, and if we subtract the 0.0240 moles of the solute, which is that, it would equal X moles of solvent. Okay, sorry, that fits in a little awkward, but anyways, so if we do that, we will get the moles of the solvent. So 1 minus 0.0240 would equal 0.97, let me rewrite that, 0.976 moles of solvent. Now again, we need kilograms, so we need to convert this into grams. So let's move over here. 0.976 moles of solvent, and our solvent, of course, is water, H2O. And so multiply that out. For every 1 mole of water, there is 18.02 grams of water. So now if we convert this, 0.976 times 18.02, we get 17.587 grams. This is grams, not kilograms. So we need to convert this, moving over 1 to, oh, this is also of solvent, sorry. So 1, 2, 3. And so we would get 0.017587. I did a couple extra sig figs because it's better to have more, so then later on you don't like have too little. And then kilograms of H2O. So now if we just divide this out, 0.024 divided by 0.017587, we will get 1.36, and there's 3 sig figs, so we stop there, molality of H2SO4. And that is our final answer.